Tapi saya tinggal ya. Ini sudah saya jadikan host. Kamu dan Bu Fitrianti sudah saya jadikan co-host. Jadi kamu share aja send screen dulu ya. Satu ya.
Oh, baik, siap Pak.
Biar di YouTube-nya tampilannya share screen kamu aja dulu.
Baik Pak.
Oke, terima kasih Bakti. Assalamualaikum.
Pak, waalaikumsalam.
Hello, good morning, Miss.
Hi, good morning.
How are you?
I'm good. I'm good. How are you?
Yeah, I'm good. And Miss Vicente has been standby in this Zoom meeting. And for the student, now we have 64 participants. And we will be start this guest lecture in 5 minutes. So for all the participants, prepare yourself and don't forget when we start the guest lecture, this guest lecture, open your camera and mute your mic. Thank you. Oke, untuk teman-teman partisipan yang lain, silahkan dihubungi lagi kawan-kawannya. Jangan lupa untuk segera join di Zoom meeting. Dan bagi yang tidak kebagian, bisa join di YouTube channel Petroleum Engineering. Dan bagi yang sudah berkenan hadir, jangan lupa untuk menghidupkan kameranya, karena kita akan melakukan absensi secara abstrak melalui kamera yang dibuka. Jadi nanti kalau kameranya tertutup, mungkin tidak akan terikut absen. Thank you. Oke, baik. Terima kasih pada teman-teman yang sudah menghidupkan kameranya. Kita hari ini akan membahas seputar tentang petroleum system. Jadi kawan-kawan jangan lupa untuk menyiapkan pertanyaan, baik melalui menggunakan bahasa Inggris ataupun bahasa Indonesia. Karena bagi yang bertanya akan mendapatkan nilai lebih yang akan kita catat namanya dan kita serahkan kepada dosen yang terkait. Terima kasih. Okay, we will start this guest lecture. Dan selamat pagi kepada seluruh partisipan dari semester 4 di Universitas Islam Riau. And good morning to Miss Alia. Welcome to join again in the guest lecture today. And actually, I'm very happy when I meet you again. It's like remembering beautiful memory of when we visit the APU, Malaysia, yesterday. And I hope that this moment can be repeated with a better relationship between Universitas Islam Riau and APU. Okay, Ms. Elia, today we are doing an interesting agenda where our theme is the petroleum system. We have an active number of Zoom meeting of 95 people and also about YouTube streaming viewers, where they are active students from the semester 4 at the Universitas Islam Riau. And before we start, there is a speak from the lecturer as the person in charge of the related courses to Miss Fitrianti STNT. We invite you to join us.
Okay. Morning, Miss. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen. Thank you for joining this event. First of all, let us praise and thank the praise of Allah Almighty and Merciful for the abundance of this and the joy of all of us still gather in this place without any barrier or and in good health. Do not forget to also say salawat and greeting to our Prophet Muhammad Sallallahu Alaihi Wasallam, who has brought as of the darkness the era of light today. May we all get intercession on the end. Amen. Thank you for taking your time to attend and share knowledge with us, especially the Universitas Islam Riau Petroleum Engineering Study Program. For all 4 semester, students to be able to follow this course well. On March 3rd, the Petroleum Engineering Study Program invite Ms. Ellie to provide the knowledge to be useful someday at the University Islam Riau of Petroleum Engineering Study Program. Hopefully, all of us build that good relation with APU will be continued. Finally, it is a few words from me. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Thank you to Ms. Fitrianti as the person in charge of the related course. Okay, let's just go ahead and give a material from Ms. Elie. And before that, I will read a little bit background of her. Ms. Elie have her real name is Nur Alie Sofiana Serasa. She is a program leader from the Petroleum Engineering Program, Asia Pacific University of Technology and Innovation, Malaysia. So, for Ms. Alie, I will give you time, and you provide us like 120 minutes of material and maybe 30 minutes later for the question and answer session. Okay, so I will give you the time.
All right. Thank you, Mr. Chairperson.
You're welcome.
All right. Let me just... All right. Could you confirm whether you can see my slide or not?
Okay, we now see your slide in the first page.
Okay. All right. Okay. All right. Okay. Good morning, everyone. Thank you again for thank you again, UIR. Okay, especially Ms. Fitrianti for giving me this opportunity again to deliver, okay, to share my knowledge, all right, on geology, all right. And today, the topic or the chapter that I would like to share with all of you, okay, with students, is the topic of petroleum system, okay. And as the chairperson has brief earlier, okay, my name is Aili, okay, and I am the program leader, okay, so that is the head of program of the Petroleum Engineering program at APU, right? And I am also the module lecturer. I am also the subject lecturer for Petroleum Geology at APU, okay? And my research interest is definitely will be in geology, okay, a little bit in drilling engineering as well as in reservoir engineering, okay. So for today's lecture, okay, we will spend approximately about 50 to 60 minutes, okay, looking into the review of petroleum system, okay, and then after that, we will spend perhaps 15-20 minutes, okay, to take up the questions and answers, right? For today's session, right, this session, this topic, okay, will be divided into several subtopic, okay, where we will look into first the definition, okay, the introduction of what is actually petroleum system, right? And then we look into what are the elements of petroleum system, okay, what is considered as a petroleum system, and then we look into the the relevancy of petroleum system, okay, all right. So let us start. When we mention petroleum system, okay, or before that, okay, when we mention exploration of oil and gas, all right, long time ago, all right, exploration of oil and gas is monopolized by the geologists, okay. They are the one who will be the main, they are the main group of people, okay, that will assist in terms of locating the next prospect of hydrocarbons. All right, that was during the old days. However, nowadays, okay, at present days, petroleum is found by geoscientists. Okay, so we have a new term for that, which is geoscientists. So when we mention geoscientists, okay, so these are a group of people that has a combination or a synergy of expertise in terms of geology, okay, geophysics, as well as engineering, okay. So if you are a geology, okay, you could also be part of the synergy that will drive the hydrocarbon exploration, okay. And to be a geoscientist means that you are valuing all these three aspects, okay, which is very important, okay. So geology is the study that is relevant to, looking at the regional geology, okay, you are looking at the past history, all right, and then you are looking at the surface map, okay, you are looking at the structure of the geology, okay, you look into the depositional environment, okay. Geophysics, okay, is the study of specific technique or methods, okay, specific techniques or methods that can be used to locate a possible prospect, okay. And engineering is whatever that is relevant to supplement the petroleum exploration and production, okay. So in terms of ensuring that you have a successful petroleum exploration, okay, you need, or that particular individual, okay, need to have the ability to critically interpret complex data from different sources, okay? And when we look at this complex data, this includes, okay, you need to be able to interpret log data. That's one. Okay, you need to be able to interpret, okay, map, right? You need to be able to also interpret structure. Okay, and the sources of this data comes in, in many forms. Okay, it can comes from the exploration well. Okay, it can comes from drilling report. Okay, and understanding, okay, the ability to interpret this data is of utmost importance. Okay, all right. So to discover hydrocarbons, we need to explore the earth. Okay, but not only whatever that we are seeing at present day. Okay, however, we still need to look back at what is actually happening in the past. Okay, so that is the evolution. Okay, we are looking at the evolution of the earth throughout the old geological times, right? So the job function of a geologist are basically to look into whatever that we are observing now at present day, okay, and try to relate on what actually happened in the past. Okay, we are trying to understand the processes that happens in the past that will explain whatever observation that we are seeing at present days. Okay, all right. And having said that, right, we all know, okay, we have established the understanding that if we were to look into the prospect of hydrocarbon fields, okay, most of the time these hydrocarbon fields are discovered in sedimentary basin. Okay, they are located or found and discovered in sedimentary basin. Okay, so sedimentary basins, okay, this is another topic, right? This is another topic. So when we look into basins, okay, when we look into basins, this involves, the basin evolution. Okay, this involves basin development. Okay, this involves the sedimentology. Okay, how sediments are deposited. Okay, so in general term, when we say basin, okay, it is a depression. Okay, it is a depression on the ground. But how does it happen? Okay, how does this depression occur? So this, like I mentioned, okay, is another topic called basin development. Okay, but just to give some insight, basin development can come from three possible factors. The first one is definitely due to tectonic forces, okay, especially the extensional forces. Okay, so this is where initially you have one plate, okay, and due to the tectonic movement, okay, it will create this structure where at this part, okay, it becomes thin, and over time, okay, sediment input and sediment supply will fill in, and this is where we can get the sedimentary basin. Okay, so that is some of the example of basin development. Okay, another thing, another reason, another factor, okay, that will lead to basin development is mantle phase change. Okay, so in terms of mantle phase change, okay, so when we look into the structure of the earth, okay, when we look into the structure of the earth, we know that we have a few earth internal structure. Okay, so you have crust, you have mantle, okay, and then you have the core, right? So mantle phase changes, okay, is whatever changes that occur on the upper level, okay, upper layer of the mantle. So the upper layer of the mantle is what we call as the noosphere. Okay, and this mantle change is basically the force that will drive. Okay, it is an internal force that will drive some of the sediment to be uplifted up. Okay, and then when it is uplifted, okay, due to erosion and etc. Okay, over time, that particular mount, okay, will be eroded away, and that hollow will be filled up with sediment. Okay. Okay, so when we look into the sedimentary basins, okay, sedimentary basins, okay, when we look into the world map, okay, they are now spread over both the continents and ocean. Okay, so these are some of the example of the sedimentary basin. All right, whatever that is in brown color is the continental basin. Okay, whatever that's on land. And labeled as blue is the ocean or marine basin, okay, whatever that's located offshore, right? So this is just some representation. This is where we are, okay? So that's all oil basin all over that, okay? Right, now that we understand, okay, a little bit of understanding on basin, okay, a little bit of understanding of basin. Definitely, okay, in order for you to understand how a basin can be considered as a prospect for oil and gas, okay, this is where the idea of petroleum system comes in, okay. So in general, petroleum systems are basically the application of geology, okay, so it's applied geology. We are applying the knowledge of geology, okay, we are applying the knowledge of geological structure. We are applying the knowledge of sedimentology, okay? We are applying the knowledge of deposition environment, okay? We are applying the knowledge of what else? Property of rock or lithology, okay? All these are the application of geology to the exploration and production of oil and gas, okay? So when we are in this line of business, okay, petroleum exploration, it means that in order for you to find hydrocarbon, okay, you need to ask yourself these three questions. Okay, you need to ask yourself these three questions. So the first question, what or which are the main geological feature at the present day and during past times? Okay, so I highlighted geological feature here. Okay, so what does it mean by geological feature? So this geological feature, all right, is whatever structure that you are observing at present day, okay, and whatever that you can be predicting during past time, okay. So example of geological features are, maybe you have lake, okay, maybe you have a hill, okay, maybe you have a beach, okay. So these are the feature that you observe at present day, okay. And by looking at this feature also, okay, you can predict what happened during past times, right? And then the second question that you have to ask yourself, okay, coming back to the first point, all right, why is it important for us to understand the geological feature? Is because this geological feature will be the potential place, okay, will be the potential place for either your hydrocarbon accumulation, okay, or the potential place for hydrocarbon generation. Okay, all right, it all depends on the feature. The second question that you need to answer yourself, that you have to ask yourself, okay, is when were the hydrocarbons generated? Okay, so in terms of when, okay, timing here is very, very important. Okay, timing is very important. Okay, why timing is important is because alongside with timing, okay, comes the maturity of your source rock. Okay, maturity of your source rock, right? So we need to be able to properly predict, okay, the time where the hydrocarbons were generated, or the possible time frame where the hydrocarbons will become fully mature, if it is immature during, at present day that you are locating it. Okay. And then the last question that you need to ask yourself, okay, is it possible to find large accumulation of oil and gas? Okay, so large accumulation, this is where we look into the reserve. Okay, this is where we look into the volume of the oil or gas. Okay, all right. So to help answer question number 1, question number 2, and question number 3, okay, geologists and geoscientists have developed a key concept called a petroleum system. This is how they are answering these 3 questions, by developing a term coined the petroleum system. Okay, so the definition of petroleum system, okay, is that a petroleum system, okay, is a system. Okay, it's a system. Your body is a system. Okay, your body is a system. So what? I'm so sorry. So what is relevant to your body system? Okay, so inside your body system, okay, you need to have nerve system. Okay, you need to have your bone system. Okay, you need to have, a lot of system that will mix up, or that will create a perfect human for you. Similarly, okay, in order for you to have or to locate oil and gas, okay, it needs to run on a system. Okay, so a petroleum system, okay, this is definition of petroleum system. All right, it includes all of the geologic elements. Okay, we are looking at the geological elements, okay, as well as the geological processes. Okay, we're looking at geological element and geological processes. Okay, it needs to have an element as well as processes. Okay, and these elements and processes are essential to exist. Okay, it needs to be there. All right, if an oil and gas accumulation is to exist. Okay, take an example. Again, if you wanted to build a car, element of a machine, a vehicle, okay, it needs to have engine, okay, it needs to have wheels, okay, it needs to have fuel injection, okay, all right. And if you remove one element, okay, for example, you remove the engine, okay, then the car or the vehicle, okay, cannot be considered as a vehicle because it won't operate. Okay, similarly like a petroleum system. Okay, if you take out one of the geological elements, if you take out one of the processes, okay, the geological processes, then your petroleum system is missing an element. Okay, all right. And when it is missing an element, then it could it is possible, okay, that the oil and gas accumulation will not exist. Okay, so that is the petroleum system. Okay, so when we are characterizing petroleum system, okay, you can characterize it in terms of the geology elements, okay, and the processes. Okay, geology elements and processes. Okay, now let's have a look at the petroleum system that is characterized by geology element. Okay, so geology is the study of rock. Am I right? Okay, that is the basic that you need to know. Geology is the study of rock. So when we look into the element of when we look into the geological elements, definitely this has to be the description of the rock. Okay, so when you look at this, all these are relevant to rocks. Okay, now the petroleum system that is characterized by geology element includes, first thing, your system need to have a source rock. Okay, your system need to have a reservoir rock, and your system need to have seal rock. So that is what it meant. Okay, all right. I provide some brief explanation, okay, on the different types of rock. However, I will be explaining this in more detail in the coming slides. Okay, now let's just quickly go through. Right. So when we say that to have a petroleum system, you need to have the presence of a source rock, okay? So when we say source rock, okay, source rock are the types of rock which could produce hydrocarbon, okay? Produce hydrocarbon, okay? And how does it produce hydrocarbon? It produces hydrocarbon from its preserved organic matter, okay? So it's a type of rock which contains preserved organic matter. So when we talk about this organic matter, this is definitely the remains of plants and animals. Okay, when they decay, when they decompose and decay, then they will become the organic matter. Okay, and one of the physical characteristics of a source rock, okay, is that it is generally an impermeable type of rock. Okay, so impermeable means that it is, it does not allow or it does not permit fluid to pass. Okay, and an example of an example of source rock. Okay, they are normally characterized by thin sediments. Okay, they are just, when we look into strata, they are just basically thin sediments. Okay, and most of the times they are of shale origin. Okay, shale origin. So shale is an example of sedimentary rock, clastic sedimentary rock. So that is the first geology element that you need to build a petroleum system. Okay, the second geology elements that you need to build a petroleum system, okay, is reservoir rock, right? So reservoir rock is the type of rock which hydrocarbons can accumulate. So see the difference. Source rock is a type of rock that will be that could produce hydrocarbon. Okay, source rock, ability to produce. Okay, and reservoir rock, ability to accumulate. So when we talk about this accumulation, so accumulation are just basically the action of collecting all of the fluid together. So it looks like a container. Okay, you can describe it as being a container or a pool. Okay, right? Over time, this is where all of the hydrocarbons will be accumulated. Okay, now reservoir rock need to be a permeable rock. Okay, it has to be a permeable rock. Okay, so it need to have the ability, the fluid that is contained within the reservoir rock must be need to be able to flow around, okay, within the reservoir rock. Okay, the example of reservoir rock includes the carbonate, okay, limestone, and sandstone. Okay, and the third geology element to build a petroleum system is seal rock. Okay, sometimes also known as cap rock. Okay, you have seal rock and cap rock, right? So this is the rock which prevents hydrocarbon leaks. So you'd have a rock that can produce hydrocarbon. You have a rock that will allow hydrocarbon to accumulate, and you need to also have a rock that will prevent this accumulated hydrocarbon to escape or to leak out. Okay, and when we mentioned that it has to be, it needs the property, okay, of a seal rock need to be an impermeable rock, okay, because you are stopping the fluid from escaping. Okay, so example of seal rock here are salt layer, okay, or even shale. Okay, you can also have clay, right? You can also have chalk. So these are some of the example of seal rock. Okay, so again, back to the idea of petroleum system. I did mention that in order for you to have a system, okay, which is the petroleum system, it needs to run on two major things: geology element and geology processes. Okay, geology element are whatever that is relevant to geology, all this type of rock. Okay, so you have source rock, you have reservoir rock, and you have sill rock. Okay, please understand the difference between these three. Source rock, ability to produce; reservoir rock, ability for the rock to accumulate hydrocarbon. Okay, that's reservoir rock. And sill rock, ability to stop fluid from leaking or escaping. Okay, so we have covered the first. We have covered the first pointer, okay, which is the geology elements. Now let's have a look at the second factor, okay, which is the geological processes. Okay, so what are these processes? Okay, petroleum system is also characterized by dynamic processes. Okay, we're looking at dynamic processes. So dynamic is something that will continuously change. Okay, it's a cycle. Okay, and these dynamic processes are due to fluid movement. Okay, so this fluid movement is, your gas, your oil, and your water. All right. Now, under the dynamic processes, okay, the geological dynamic processes here, okay, you need to understand two things. The first process is the migration of hydrocarbon, and the second process is trapping. Okay, let's have a look at the first process, which is the migration of hydrocarbon. Okay, the migration of hydrocarbon. So migration, okay, migrasi. So that is basically the movement, okay, from one place to another. Okay, you migrate from one place to a new place, to another place. Okay, so migration of hydrocarbon will only happen after source rock has produced the hydrocarbon. Okay, after source rock has produced the hydrocarbon. Okay, then only you will have fluid movement. Okay, so this fluid movement is what we call as the migration. Okay, so once the organic matter has been transformed from kerosene to oil or gas, okay, so there is a new term there called kerosene. Okay, so kerosene are basically the first material, okay, that you derive from the organic matter. Okay, so we will revisit kerosene after this. Okay, so again, once the organic matter has been transformed from kerosene to oil, from kerosene to gas, or from kerosene to oil and gas, now it could be expelled. Okay, so expel here bisa dikeluarkan. Okay, so it could be expelled from the source rock under specific condition. Okay, so it means that once the source rock has generated your oil and gas, okay, this oil and gas need to be expelled from the source rock. Okay, and it can only be expelled under specific condition. All right, now why does the oil and gas need to be expelled? Okay, why can't it just stay in the source rock? Okay, if you look into the definition, if you look into the property of source rock, okay, so you can see that source rock here is an impermeable rock. So impermeable rock is not really an ideal place for you to explore. Okay, fluid will not flow basically. Okay, if you drill a well, because of the property is being impermeable, okay, when you drill a well, the fluid will not flow into your producing well. Okay, so that is the problem with impermeable rock layer. Okay, so therefore, this oil and gas that has been produced, that has been generated from source rock, need to migrate somewhere. Okay, but where? It has to migrate from the source rock to the reservoir rock. Okay, because reservoir rock is the type of rock that will allow oil and gas to accumulate, and it is also the type of rock, okay, that is permeable. Okay, that is permeable, right? So this is what it meant. Okay, hydrocarbons continue to move across the permeable sediments and fault to reach the reservoir rock. Okay, so you're basically having a movement. Okay, you're having a movement. Okay, you have a migration of hydrocarbon from the source rock to reservoir rock. Okay, all right. Now, when we look into this migration, okay, migration can take place over very short or very long distance. Okay, can take place over very short or very long distance, depending on your strata, depending on your layer. Okay, so that is the first dynamic process, which is migration. The second process is trapping. Okay, the second process is what we call as trapping. Okay, all right. So in terms of trapping, this is where basically you are preventing fluid to escape. Okay, you are preventing the fluid to escape, right? So in this process called trapping, a large volume of hydrocarbon migrating into a trap results in a fluid or gas accumulation. So in this case, you already have migration of hydrocarbon from the source rock to reservoir rock, okay? And to prevent the fluid to further migrate outside the reservoir rock, you need to have trap, okay? You need to stop it, okay? You need to stop it, right? So, so when you try to stop it, okay, so this is where we look into the seal rock, okay, since it is an impermeable. Once the fluid reach the seal rock, okay, under specific geology structure, it won't be able to further move. So it will just stay within the reservoir rock, waiting for it to be explored. Okay, all right. And over time, okay, this is where you will see the orientation of the fluid in the reservoir, where you have gas on top, oil, and then water. So they are, once they are trapped there, then they will try to, adjust and position themselves, okay, depending on the density difference. Okay, right? So that is what is needed for you to build a petroleum system. Okay, having said that, this is what we call as element of petroleum system. Okay, you need to have a source rock, you need to have reservoir rock, we need to have seal, you need to have migration and trapping. If you don't have reservoir rock, you won't have a petroleum system. Okay, if you don't have trap, you won't have petroleum system. Okay, these are the 5 elements of petroleum system. Okay, so from here, okay, based on these 5 points, okay, I will be explaining in more detail, okay, about what is source rock, what is trap, what is seal. Okay, now let's start excuse me, with the source rock. Okay, let's start with the source rock first. A source rock, okay, rock, we are looking at rock. Okay, it consists of fine grained sediment. Okay, fine grained sediment, something that is very small in particulars. Okay, small in particulars. All right, and it is rich in organic matter. Okay, so organic matter is the remains of plants and the remains of animals. Okay, and this source rock could generate crude or natural gas, okay, after thermal alteration. Okay, so thermal alteration are basically cooking. Okay, you are generating hydrocarbon by maturing it. Okay, so this is where this is where this organic matter is subjected under intense pressure and intense temperature. Okay, so given here is an example. Okay, if you go to the field, one of the activity that you should be looking at, okay, or one of the activity that you should be doing, okay, is in terms of creating an analogy. Okay, creating an analogy, okay, of a petroleum system. Okay, since reservoir is underground, we can't possibly see, or we can't actually, you know, it's very difficult for us to visualize, okay, how a petroleum system would look like. So therefore, on surface level, on ground level, this is where we do analogy study, where we go and look into a formation, we look into an outcrop, and we try to visualize, okay, how this petroleum system would look like. Okay, all right. So given here in this example, okay, is a field observation. And from the color of it, okay, from the color and, you know, rough observation of it, we can roughly tell that this is a shale layer and this is a sandstone layer because it is, you know, brown, yellowish in color. Okay, and this is shale, dark gray to black color. All right. So when you have this observation, okay, then what you can do, okay, is to look into the possibility that this shale can become a source rock, okay, all right? Where does this source rock comes from? What is the origin of source rock? Okay, so this source rock, okay, petroleum source rock are of terrestrial and marine origin. Okay, so terrestrial is land or continental. So what I'm trying to say here in the first sentence is that this shale, okay, we want to know how or where does it originate. Okay, so this source rock originates from the land and from marine origin or marine environment. Okay, you will also learn deposition environment. Okay, maybe you have learned deposition environment. Okay, so deposition environment are basically a place where your sediment will settle. Okay, a place where sediment will settle. Okay, so this could be settled, this sediment can settle maybe on land, this sediment can settle maybe in the marine origin, okay, in water. Okay, so when we look into terrestrial source rock, okay, when we look at the source rock that is deposited in a terrestrial environment, we call them as terrestrial source rock. Okay, they are normally deposited in lake, in delta, and in river basin. Okay, lake, delta, and river basin. Okay, so these are some of the example of terrestrial depositional environment. Okay, and then you have the marine source rock. Okay, so it means that your organic matter can also decay and decompose, but in marine setting. Okay, all right. So example of marine environment includes your continental slope, okay, your continental rise, okay, anything that is in water. Okay, however, under both setting, okay, which is your terrestrial and marine environment, okay, this this organic matter, okay, they are buried under no oxygen condition to become kerogen. So this is where you have organic matter. Then you have kerogen. Then you have oil or gas. Okay, so in order for organic matter to be transformed to become kerogen, it needs to have heat and pressure. Okay, all right. So you have the process here called maturation. Thermal maturation. Okay, so that is the source rock. Okay, so this is just giving you an example of many types of depositional environment. Okay, whatever that you see on land is what we call as terrestrial. Okay, whatever that is in between land and water, we call it transitional. And whatever that is in here, okay, we call it as marine. Okay, sometimes these two are also called as marine. Okay, if you are looking at transitional, whatever that is here, we can also call it as shallow marine. Okay, because they are, at shallow depth. Okay, so example of deposition environment in terrestrial on land, okay, is you have lake, you have fluvial river, okay, you have alluvial fan, you have glacier, okay, and then you have dunes. Okay, all right. And then in the transitional, this is where you have both of the elements, the land and water. Okay, so example of it is beach, okay, delta, all right, barrier island, tidal flats. That is the example of transitional depositional environment. Okay, and then you have marine setting. Okay, so under marine setting, this is completely underwater. Okay, so this is where you have deep marine, okay, the seafloor, okay, you have reef, okay, you have continental slope, continental rise. Okay, that is some of the example. But again, this is another topic. Okay, this is another topic. So this is if you're looking into the maturation of kerogen, okay, I did mention before. So you have organic matter, okay, cooked together to become kerogen, okay, and this kerogen can be further can further mature to become different types of hydrocarbon. Okay, all right. So it started from all this material. Okay, so you have carbohydrate, protein, lipid, lignin. Okay, this exists in organic matter. Okay, this is your organic matter. Okay, all right. So organic matter, anything that is organic, basically. Humans are organic. Okay, inside human, we have carbohydrate, we have protein, okay, we have lipid, okay, all right, on a DNA level. And under correct timing, under proper temperature and pressure, okay, this organic matter will mature to become kerogen. Okay, and if this kerogen is further subjected under specific condition, then it will become hydrocarbon. Okay, so we have 4 types of kerogen. We have type 1, type 2, type 3, and type 4. Okay, type 1 and a little bit of type 2 is from aquatic origin, and a little bit of type 2, type 3, and type 4 is of terrestrial origin. Okay, so if you go back again to this is where it is. Source rock are of either terrestrial or marine origin. Okay, so that could be under marine and terrestrial. Okay, so this is a very good table which shows you that if you know, basically if you know where the source rocks were deposited, okay, or when you know the origin of source rock. Sorry. If you know the origin of source rock, okay, you can basically predict the type of hydrocarbon, okay, the potential of hydrocarbon just by looking at the setting of the source rock. For example, you know that your source rock will deposited on land, okay, in the terrestrial, okay, and when you study your organic matter, okay, when you study your organic matter, the contents of the organic matter, okay, contains all this, okay, it contains remains of plants. So when you have remains of plants only accumulated in the terrestrial setting, okay, high chance that you will get gas. Okay, if you have dead animals, okay, animal remains and plant remains, your hydrocarbon potential will be oil. Okay, so that is how we look at it. Okay, so that's why most of the time, okay, when you look into the oil field, okay, a majority of the oil field that is in onshore, they are producing gas, okay, and majority of the oil field that is located offshore, okay, producing oil. But that also depends, okay, depends on the processes that have occurred. Okay, all right. So this is, you know, some cheat sheet that you can use to look into the potential hydrocarbon potential. Okay. Now, the second part, okay, is the second element of petroleum system is the reservoir rock. Okay, that's the reservoir rock. So we know that for source rock, it's a type of rock that is able to produce hydrocarbon. Okay, and reservoir rock is a type of rock that will be able to contain, okay, or store your fluid inside because it is permeable. Okay, because it is permeable. So this fluid are, you know, water, oil, gas. Okay, this is the example of the fluids, right? And example of source rock are shale. Okay, an example of reservoir rock, okay, are dominantly sedimentary rocks. Okay, that includes your sandstone and carbonate, and a little bit of igneous and metamorphic rock, but only a few fraction of it. Okay, all right. Now, in order for you to have as a reservoir rock, okay, in order for you to have a reservoir rock, okay, your reservoir rock must possess this four property. Okay, it needs to have good permeability and porosity. It needs to have good wettability and capillary pressure. Okay, if your reservoir rock is porous but it is not permeable, then you will need to do something to stimulate, okay, the fluid movement in your reservoir rock. So this is where you look at, you know, fracturing. Okay, so you are creating a secondary pathway for your fluid to pass. Not all rock that is porous is permeable. Okay, not all rock that is porous is permeable. Okay, all right. So the image here shows you the property of reservoir rock in terms of the porosity and permeability. This is a very low porosity and low permeability rock. Why? You can see that there is no spaces in between one grain to another. Okay, and it has low permeability because where can fluid pass? Okay, imagine you are stuck in traffic jam. Okay, you have a lot of cars stuck there. Okay, it is very compact, right? So let's suppose you have another car wanted to come in, okay, or another like a small car. Okay, it cannot pass through, right? Because there is no pathway for it to pass through. Okay, similar like this one. Okay, and then this is an example of a porous rock, but it is not permeable. Okay, porous means that, okay, you have one space here, you have one space here, you have another space here, and then another space here. Within these spaces, this is where fluid will be trapped. Okay, so please don't confuse that, because some students, okay, they confuse that hydrocarbon are actually located inside this. No, hydrocarbon are located within this pores. So this is what we call as porosity, keliangan. I think so. Are we using the same term? I'm not sure. I think so. Okay, so inside here. So when you look at these individual pores, okay, this fluid are in not this fluid is in no connection with this fluid. Okay, it cannot travel to this one, to this pores. This fluid cannot travel to these pores. So in this case, we can say that it has good porosity, but not the permeability. Okay, and the best property of a reservoir rock is where you have connected. Okay, you have good porosity and good permeability. Okay, so you have pores, and the pores are interconnected. Okay, all right. So in this case, fluid can flow freely. This is the condition that we want. Okay. So that is the first two, which is the porosity and permeability. Let's have a look at the third property of reservoir rock called wettability. Okay, so what is actually wettability? Wettability is defined as the tendency of the fluid to spread on a surface. So let's say you take an example. Okay, take an example, do some little experiment. Okay, on your table, okay, you take one drop of water, okay, drop it on your surface, and you take one drop of oil or honey or anything that is high viscosity. You will see that water is able to spread on the table. But when you drop oil, okay, you can see that at microscopic level, okay, it looks something like this. Okay, it looks something like this. Okay, and when you take soap or surfactant, okay, and you drop it on the water, you can see that it is almost, you know, spread all over. This is wettability, the ability of the fluid to spread on solid surface. Okay, right? Wettability, if you study reservoir engineering, wettability is very, very important. Okay, why? Because this property, okay, tells you whether you will have problem in terms of fluid flow or not. Okay, all right. So we have three types of wettability. Okay, so we have water wet, mix, and oil wet. Okay, so when you look at the example, it kind of looks the same, but it is not actually. Okay, it is not. So coming back to the general definition, okay, wettability is the tendency of the fluid to spread on a solid surface. So in this case, our solid surface is your rock. Okay, this is your solid surface. And the tendency of the fluid to spread on it is the wettability. So when you have water wet, whatever that is spread on your solid is water. Okay, when you have oil wet, whatever that is spread or that is, you know, that is cling. Okay, that is cling or stuck, or yeah, any definition will do. Okay, is oil here. Okay, so look at this color. Okay, this is green color is oil, blue color is brine, and this is your rock. Okay, so you can see that blue color is here and a green color here. Now, when we look into this, okay, which one is the better property? Do you need to have water wet reservoir, or do you prefer to have oil wet? That is the question that you have to ask yourself. Okay, all right. In the study of reservoir engineering, okay, we always prefer our reservoir to be a water wet. Okay, we do not want oil to be attached to the fluid, to the grains. We want oil to move Okay, we need oil to move. We don't want oil to be stuck here. Okay, because you want to produce oil, you don't want to produce water. So that's why we prefer to have water-wet reservoir. Okay, in an oil wet reservoir, this is where you have water movement, but not oil movement, because oil is attached to your rock grain. Okay, and later on when you study when you study flooding, okay, water flooding and all that, this is where you see that we are trying, if you were to work with an oil wet reservoir, okay, so you do flooding to change the wettability, okay, the property of the reservoir. Okay, we want to change it from having oil wet, okay, to water wet. And how we do it, okay, is by altering the interfacial tension between these two surfaces. Okay, so that is the third property of a good reservoir rock, which is wettability. And the last property is the capillary pressure. Okay, so capillary pressure, when we talk about capillary pressure, all right, inside the reservoir, okay, reservoir contains immiscible phases, okay. You do not have only water in your reservoir, you do not have only oil in the reservoir, okay. Oftentimes, okay, 90% of the times you will have immiscible phase, means that you have more than one phase in your reservoir, okay. So you have oil and gas, oil and water, gas and water, okay. That is what we call as the immiscible phases. So have you ever wondered how does this phases coexist? How are they in equilibrium? Okay, so they were hold, okay, they were hold or put together by a force called the capillary force or the capillary pressure. Okay, the capillary pressure. Okay, so capillary forces are basically the forces that will hold or will bind this multi-phase in equilibrium with each other. Okay, so that is capillary pressure. Okay, so understand that. Four property of a reservoir rock: porosity, permeability, wettability, and capillary pressure. Okay, now we move into seal rock. Okay, we are almost there. Okay, we move into seal rock. So we know that seal rock is a layer of rock that is impermeable, that stops further migration of fluid from escaping. Okay, so usually seal rock forms a barrier or a cap above and around reservoir rock. So when you are looking at this structure, okay, your seal rock could be here. Okay, this upper layer, and then you have your reservoir rock and you have your source rock. This is reservoir, this is your cap. So your fluid cannot escape, it will just stuck here. So when you drill here. Okay, you don't have to worry that your fluid will escape. Okay, so example of seal rock are shale, mudstone, anhydrite, salt, anything. Okay, any lithology that is impermeable. Okay, all right. And seal is a very, very critical component of a complete petroleum system, because we want hydrocarbon to stay there. Okay, we don't want them to, move around. It's going to be difficult for us to chase the hydrocarbon. We want them to be there, okay, waiting for us to explore and drill them. Okay, that is seal, right? So this is an example of a seal. So whatever that you're seeing here, mana saya punya seal? Okay, this one, right? Pink color. This is your seal. So you can see that this is your seal. This is your reservoir rock. Okay, and this is your source rock. Okay, so fluid will migrate from source rock to reservoir rock. Okay, and then it will just stay here because it has a seal on top of it. Okay. And then we have trap. Okay, trap. Remember the second. Okay, but in this case, it's the first one. we look into the dynamic processes of a petroleum system, which is trapping and migration. Okay, so we look at trap first. Okay, then we look at migration, right? So what is trap? Trap is just basically a configuration of rock. Okay, how can you collect water? You can collect water in a glass. You can collect water in a glass. Cannot see. Okay, you can collect water in a bottle. Okay, you can collect water in any container, similar like trap. Okay, you can trap hydrocarbon in any configuration of rock, which what we call as structure. Okay, all right. You have two types of trap: structural trap and stratigraphic trap. Okay, the other two uncommon trap, okay, is the combination trap, where it has a mixture of one of this and also hydrodynamic. Okay, but let's have a look at the most common types of trap, which is the structure and the stratigraphy. Structural trap, okay, is a type of hydrocarbon traps that form in geology structure. Means that the structure that you see. Okay, this includes your anticline, your fault, your salt dome, that is structural trap. Okay, so when you study geology structure, okay, the structure that you are observing now, okay, is the results of rock deformation due to stresses, depending on what stress. You have shear stress, you have fault. Okay, you have tension, you have basin. Okay, you have compression, you have folding. So that is structural trap. Okay, so that is the structural trap. Okay, and then you have stratigraphy trap. Okay, so in a stratigraphy trap, this is whatever that is relevant to your strata. Okay, this is strata, your layer or your bedding. So example of stratigraphy trap is when you have sand lens, okay, when you have a pinch out in the edge of the basin, or actually have picture. Okay, yeah, sorry. So this is the example of a structural trap. So this is due to shear force. Okay, this is an anticline due to the compression force. Okay, and the dome is also due to compression, and then one more. Okay, you have a basin. This is due to extensional. Okay, this is structural trap, and this is the example. Okay, all right. So as a geologist, okay, this is what you should do. Okay, this is one of the example of a structural trap in field example. Okay, if you are not a geologist, okay, in normal eyes, what you see are just sand. Okay, what you see is just rock. Okay, but to be a petroleum engineer, to be a geoscientist, to be a geologist, okay, whatever course that you are in, okay, if you study hydrocarbon exploration, you should be able to predict what you are actually looking at here. Okay, so this is what we call as field analogy. Okay, so you look at the outcrop, okay, and then you try to visualize what could it be. So in this case, what it seems to be like is that you have fault. Okay, again, I play, right? You have fault here. Okay, and then when you look at the layer, okay, this layer is similar to this layer, and this similar to this layer. Okay, all right. And where can hydrocarbon be accumulated? Hydrocarbon can, or before that, you can have a reservoir rock, okay, depending on the type of lithology. So let's suppose that you look at this, okay, and then upon observation, you know that, okay, this is shale, this is actually your sandstone layer, and then down here is another shale. Then you can say that if I were to create an analogy of a petroleum system, okay, this is my source rock, this is my reservoir rock, and this is my trap, okay, or my seal rock, and my hydrocarbon will be trapped somewhere along the fault, okay, somewhere along the fault. Okay, so this is where oil can be trapped. Okay, this is an example of a stratigraphy trap, okay, based on the layer, based on the strata. So you have pinch out. So pinch out is, you have a basin, right? So pinch out is the edge of the basin, okay, that end part of the basin. Okay, and then you have also, this is unconformity. This is where you have an area, and then something occurred here, okay, erosion and everything, it creates this depression, and over time sediment will accumulate. Okay, so this is your typical basin. And you also have reef, okay, platform carbonates, okay, oil are basically deposited up here. All this type of trap are called the stratigraphy trap. Let's have an example of let's look at an example of a field stratigraphy. Okay, so in this case, again, if you don't study oil and gas, whatever that you're seeing is just a very beautiful mountain. Okay, but if you are a geologist, okay, you have the eye to see that this can be visualized in terms of analogy of petroleum system. Okay, it looks like a pinch out, maybe. Okay, so let's have a look at what does it look like. Okay, it is actually a pinch out. Okay, and if you were to have another an example, okay, of petroleum system, however, in this case you do not have structure or you don't have stratigraphy, okay, whatever that you are seeing here is just an outcrop with a lot of fracture, okay, with a lot of fracture. So this, okay, where is my animation? Okay, so in this case, hydrocarbon will be trapped within this fracture. Okay, so this is the concept of basement reservoir. Okay, this is where oil and gas is trapped inside igneous rock or metamorphic rock. Okay, since igneous rock and metamorphic rock has very low permeability and porosity, all of the oil and gas are trapped within the fracture. Okay, within the fracture. Okay, so these are some of the example of the field observation. Okay, and then we move to the another dynamic forces, which is migration. Okay, right? Migration is the movement. Okay, movement of oil or gas from one place to another. Okay, and when we say migration, okay, hydrocarbon always migrates upward. Okay, they always tend to migrate upward. Okay, sometimes they can migrate to the side, but that depends on several conditions. So this is the condition where you have a really tilted reservoir. So in this case, your migration will occur laterally. Okay, however, majority of the hydrocarbon will migrate in an upward, okay, upward movement. Okay, naik ke atas, right? We have two types of migration. Okay, you have the primary and secondary migration. Another type is tertiary. Okay, another type is tertiary. So let's have a look at what is actually primary migration, or before that. This is another explanation of migration. Okay, this is where, you know, once you have a mature hydrocarbon that was developed or generated in the source rock, okay, they are ready. Okay, they are ready to travel to reservoir rock. And when they travel to reservoir rock, they travel in an upward position, okay, in a rising condition. Okay, and then they will rise until they were accumulated in the reservoir rock. Okay, all right. So like what it says here, okay, oil and gas migrate upwards through the rock in much the same way as, you know, the bubble that a scuba diver produce during their diving. Okay, so when you go diving, okay, when you breathe, you have bubbles. Okay, and the bubbles do not travel forward. Okay, it will travel upwards. Okay, so that's similar like migration of oil and gas. This is definition of primary and secondary migration. Okay, so the primary migration is the movement of hydrocarbon from source rock to the reservoir rock. That is primary migration. Okay, primary migration need to happen. Okay, because we want the oil and gas to be accumulated in reservoir rock. Right, and the secondary migration is the movement of generated fluids along your reservoir rock. Okay, I will show you a picture later. And the tertiary migration occurs when you do not have a seal. Okay, you don't have a seal, or your seal somehow fracture. Okay, then this is where you have, escape of the fluid into maybe to the seabed or underground water. Okay, this is how it looked like. Okay, so you have primary migration. Okay, so this is where, okay, this is your source rock, yeah. This is your carrier or your reservoir rock. Okay, so in a primary migration, this is the pathway. Okay, so this is the pathway. Hydrocarbon will migrate from source rock to the reservoir rock. Okay, from source rock, migrate upwards to the reservoir rock. Okay, all right. And in a secondary migration, what you have, okay, is the movement of hydrocarbon along this reservoir rock until they reach a specific structure or trap. So in this case, you can see again, this is the movement of pathway of hydrocarbon. Okay, it will move until it found a structure called trap. Okay, all right. And sometimes you will also have tertiary migration. For tertiary migration, let's suppose on top of your gas, you don't have a seal. Okay, so once the hydrocarbon reach this, okay, it will further escape. Okay, it will further escape. So this is where you see some phenomena where you have a lake, okay, you have a tasik, okay, and then I think it was somewhere in the US, okay, where the lake is on fire. Okay, why? Because it has methane, okay, gas methane leakage. Okay, so that what happened when the hydrocarbon seeps through, okay, to the surface. That is tertiary migration. Okay, so I did mention in the earlier, okay, in the beginning that source rock is impermeable. Now, if it's impermeable, how is it possible for oil and gas to travel from source rock to reservoir rock? That is the question that you also have to ask yourself. Okay, so in terms of migration, okay, when hydrocarbon is generated from the source rock, okay, when it travels to the when it travels to the reservoir rock, okay, it does not migrate, or it does not travel in the sense that it travel like, gas travel together and oil travels together. No. Okay, they travel, I think, do I have it here? No. Okay, it travel in terms of okay, yeah, this is where it is. Oil and gas migrates in diffusion, okay? It is in individual molecules, okay? They migrate in diffusion or they migrate in solution, okay? So only, droplets, okay? Droplets of hydrocarbon will migrate, okay? And then once they reach the reservoir rock, this is where they will accumulate. They will come together. Similar, like, if you have a team of 12 people and then you say, okay, let's go to lunch, okay, and then let's gather there. So all of you will travel from your own respective places individually. Okay, once you reach your cafe, then only you group together, similar like that. Okay, they migrate in diffusion or they migrate in solution. Okay, right. So when we look into the secondary migration, that was just now the primary migration, how they migrate, okay, via diffusion. Okay, in terms of secondary migration, okay, secondary migration is where you look into, accumulation of oil and gas and how they were sequenced, okay, how they are accumulated together. Okay, So they accumulated together due to several forces. Okay, the first one is buoyancy. Okay, difference in density, right? Gas will be on top, followed by oil and water. Okay, so actually buoyancy is the main driving force for oil or gas migration within the reservoir rock. Okay, that is the first force. The second force is hydrodynamic force. So hydrodynamic force is in terms of, density of water. Water that has, fresh water versus saline water, okay, has different density. Okay, it depends on structural tilting, okay, and it also depends on the tectonic forces. All these are, based on external fluid forces, basically. This will also affect your secondary migration. Okay, and the last force in secondary migration is the capillary forces. Okay, how the forces are in equilibrium. Okay, all right. So we have two factors. The factor that will affect migration in primary migration is just basically, how fluids are migrating in primary migration is by droplets or solution or molecules. Okay, and in terms of secondary migration, fluids are accumulated, are brought together by these three factors: capillary force, buoyancy, and hydrodynamic factor. Okay, all right. Now, when we look into the distance, okay, about 60% of the reservoir worldwide appear to have accumulated due to vertical migration. Okay, remember just now I said that migration occur in a upward, okay, upwards. So it is in a vertical migration. Okay, so 60% of the reservoir, okay, 60% of the reservoir worldwide appear to have accumulated due to vertical migration, and the other 40 due to lateral migration. So these lateral migration are basically when you have thin layer, or when you have a very extensive, okay, when you have a very extensive layer, okay, right? Also, migration will also depend on the size of the basin. Okay, how big is your basin? Okay, if your basin is big, then all of these factors will also come in play, right? And when we look into the efficiency between vertical migration and lateral migration, definitely the vertical migration is much more efficient than the lateral migration. Okay, all right. So that's basically the that's basically in terms of pathway. Okay, how and how far can they travel? Okay, so when you combine all these elements of petroleum system together, this is how it look like. Okay, this is how it should look like. You need to have a source rock. You need to have a reservoir rock, seal, migration from source rock to reservoir rock. Okay, you need to have a structure or trap. Okay, and when you have this, then you can have prospect of hydrocarbon. Okay, potential of hydrocarbon. Right, so that is the element of petroleum system. In conclusion, okay, in conclusion, right, petroleum system analysis, okay, petroleum system is very important, okay, for if we're looking at conventional exploration. Okay, conventional exploration means we are looking at conventional resources, not unconventional. Okay, unconventional is coal bed methane, gas hydrate, shale gas, tight sand. Okay, so this petroleum system is only applicable when we are looking at conventional reserve and conventional exploration, right? If you are looking at unconventional. So this is where you have, your source rock is also the reservoir rock. Okay, this is shale gas exploration or shale oil exploration. Okay, all right. In unconventional reservoir, okay, the source rock is, like I said, it can be your source rock. It can also be your reservoir rock. Okay, it doesn't have, or it does not contain a reservoir rock. Okay, so that's why it is considered as unconventional reservoir. Okay, because it is unusual. The system is not complete. Okay, the system is not complete, so therefore it is considered as unconventional reserve. Okay, all right. And then when we look into this factor of of elements of petroleum system, okay, we are more interested in the retention, okay, in the ability of the fluid to be accumulated and retained, okay, to be trapped, rather than the migration distance. Okay, that is another factor that reservoir engineer have to also consider. Okay, all right. And that concludes my lecture for today. But I'm going to do something different now, okay? I want to test out of the hundreds that is with me, okay, how many of you are actually paying attention, right? So I'm not sure whether you have used Kahoot before. I think you are familiar with Kahoot, am I right?
Yep, you're right.
Okay, very good. Okay, so let me just set up my Kahoot. So let's play the game a little bit first, okay, before we go with question and answer.
Oke, semuanya untuk kawan-kawan silahkan buka website kahoot.it. Nanti kita akan ada pin-nya yang akan di-share, nanti kawan-kawan akan mencoba untuk lakukan jawab pertanyaan secara cepat.
Okay.
Kahoot.
So in Kahoot, okay, you have to use your mobile, okay, use your mobile, all right, and type kahoot.it. Okay, kahoot.it.
Okay, I'm ready.
Right, and then you need to enter your PIN, all right, and the PIN number, let me just share my screen again. Are you seeing my screen?
Okay, I see your screen.
Okay.
The game pin is 299.
So you
9,
enter
5,
the game
6,
PIN.
Oke, teman-teman silahkan masukin game pin-nya yang 2999565 ini di kahoot.it.
And then enter your nickname.
Oke. Jangan lupa kasih nama yang jelas ya. Oke, baru ada sekitar. Oke, terus masuk.
Okay, so let's stretch up a bit, wait for other players, okay?
Okay.
Let's wait until we have maybe 70. Or I think Kahoot has a limit of 50 players. So let's wait for 50 players.
Okay,
yeah, let's wait for first 50 players.
Oke, jadi kita terbatas di Kahoot ini untuk 50 orang pertama. Jadi silahkan, nanti sisanya kita akan join lagi 50 orang. Udah 18 orang. Oke, 19. Nanti ini akan terhenti saat 50 ya, jadi silahkan. Oke, ada yang masukin namanya PIN 2995. Don't forget, unique name is your name, and then the game PIN is the number of PIN. Okay, 27. Okay, 33. Okay. Check. Okay. And 8 people again. We're ready to take off.
Oh, wow. It's really fast.
43, 44. Okay, 6 people. 4 and 5. Okay.
I have never played Kahoot with this maximum participants. My students' number are just 10, 15.
Okay, maybe this student really excited for
Yes,
you.
it's going to be very interesting.
Very interesting.
Come on, last 3
Okay,
players.
3 player, 2 player, and we're ready to take off. Okay, it's 15.
All right.
Oh.
Okay, that's very interesting. We can still admit. Okay.
Yep.
All right. So for those of you who are not familiar with Kahoot, all right,
Yep.
you need to answer using your phone. Okay, answer using your phone. Look at my screen for question. Look at my screen for question and answer using your phone. Okay. And the winner, okay, is taken at the speed on how fast you answer. Okay, although your answer is incorrect, okay, but sometimes when they do the recording, okay, if you answer correctly and in quickly, okay, then you will get the points. Okay, all right. So again, look at my screen for question and answer using your mobile. Okay, all right.
Oke, jadi siap-siap pertanyaannya akan ada di layar dan langsung jawab di HP kalian. Dan jawaban yang benar nanti akan terlihat dan jawaban yang salah akan terlihat juga. Yang paling banyak jawab benar dia akan berada nomor urut yang paling atas. So, stand by and your screen and your phone.
Okay, ready?
Okay.
Should we play?
Okay.
So I have 12 questions. Okay, the first 2-3 questions you will feel a little bit like funny or strange, but after the third questions, okay, you will get the hang of it. Okay, you will get the hang of it. Right? Okay, so let's begin. Okay, ready? 3, 2. Okay, I'm not going to lock the participant. Okay, whoever that managed to comes in, they can just join. Okay.
Okay.
1. Let's start. All right. Okay. So I forgot to mention that you only have 20 seconds to answer. Okay. So the question is, what is the topic of today's lecture? And surprisingly, some people are still asleep. They don't know what topic are we in. Okay.
I think we have a storm problem.
Our topic is petroleum system. Okay, petroleum system. Okay, your subject is petroleum geology. All right, and your course is petroleum engineering. Okay. All right. Let's see who is on our podium. Okay, well done. We have YB Zen. Okay, we have Abdurrahman, Rahmi, Dita Putri, and Aldria on the podium. Okay, on the scoreboard. Question number 2. Ready? True or false? Two, 1. Time's up. Hydrocarbon fields are discovered in sedimentary basin. Yes, it is true. Okay, majority of the hydrocarbon fields are discovered in sedimentary basin. Okay, all right. Now let's have a look at our scoreboard. Okay, we have a new player. Okay, we have Hardina in our scoreboard, on our scoreboard. Question number 3. Okay, all right. Which of the following doesn't characterize the geology component? Okay, so when we look into element of petroleum system, we are looking at 2 different geology element. Okay, we're looking into 2 major element, geological element and geological processes. Geological element is, whatever that is relevant to your rock, and geological processes is whatever that is relevant to hydrodynamic forces. Okay, so geological element is you need to have a source rock, reservoir rock, and seal. And for geological processes, you need to have migration and trapping. Okay, all right, let's have a look at our scoreboard. Yeah, we have a new champion. Okay, and we also have Inda. Or basically we have 4 new players. Sorry, 4 new champions. Okay. All right. Next question.
We press F.
Okay, so this is a tough one. Okay. This is in terms of depositional environment. Okay. So I did mention in my slides that we are looking at the source rock. Okay. Where do they belong? Okay. So they either belong in terrestrial environment or marine environment. Okay. Terrestrial environment, okay, is whatever that is on land. And marine environment, okay, is actually whatever that is in the marine setting. Okay. So in this case, beach is actually a marine or a transitional setting. Actually, if we are looking at if we are looking at the 3 classification, means terrestrial, transitional, and marine. Okay, actually beach and delta is a correct answer. Okay, I forgot to change this. Okay, beach and delta is actually the correct answer. Right, these 2 does not belong to terrestrial sedimentary environment. Okay. All right. We have 3,225 points. Okay, so this is closing by. Next question. Okay, so if you answer this wrongly, means that you are not focusing. Okay, you are not focusing. Okay, we have 5 elements of petroleum system. Okay, source rock, reservoir rock, seal, trap, migration. Okay, geochemistry does not belong to petroleum system. So 22 students answer wrongly, sleeping. Okay, let's have a look at our scoreboard. Okay, still leading. Okay, but it's a close points, right? Next question. True or false? Come on, guys. Source rock. What is source rock? Source rock is the type of rock that is generating or producing fluids. Okay. Rock that has the ability to store is reservoir rock. So in this case, this is false. Okay. This statement is for reservoir rock. Okay. Oh, we have a new player. We have Habib. Okay, we have Habib on our scoreboard. All right, so this is a good point, okay, over 800, 900 points, okay. Next question. Okay, so in order for you to have a good reservoir rock, you need to fulfill four property. Four property. Porosity. Okay, porosity, permeability, wettability, and capillary pressure. Okay, so the answer here is wettability. Okay, only 8 scored correctly. Show your answer, whoever that scored correctly out of 100. Very good. You are paying attention throughout the end of my lecture. Okay. Yeah, we have a new player. Okay, we have a new player. We have Adrian Hidayat, new player. Okay. Question number 8. Look at the picture. Okay, so this is a tricky one, okay, because you have time constraint and then you have to visualize, okay, you have to analyze the picture, okay. So in this case, this is an oil wet reservoir because oil is actually attached to your rock grain, okay. All right, so that is the wettability. Wow, okay. All right, we have a new leader. Okay, we have a new leader. Question number 9. 5 more questions to go. Okay, so we have 2 types of trap. We have structural and stratigraphy. Structural trap, okay, is whatever that were developed, okay, from why am I seeing my screen like
okay. Mungkin bagi teman-teman yang nyoret-nyoret ini, screen bisa kelihatan orangnya di sini. Tolong dihentikan ya. Namanya, jadi Miss, you can out from your screen and okay.
Okay, never mind. All right. So we have 2 types of trap: structure and stratigraphy. Structure will form due to the tectonic forces, okay, and then you have the stratigraphy based on the strata. Sorry. So anticline is due to structure. Okay. So our scoreboard, Zadira, are you still leading? Okay. Very, very far ahead, 7,000 points to 5,000 points. Come on, guys.
Zadira is too strong.
3 more questions. 3, 2, 1. Okay, so the other 14 students, okay, they just joined the last 30 minutes and no, they joined late. Okay, they joined late, so they don't know what's actually happening. All right, so produced hydrocarbon migrates upward. Okay, it migrates upward. Okay, very good. Oh my gosh. Okay, it's very impossible for you to catch. Okay, at 1,000 points to 6,000 points. Okay, but this is a close tie between number 2 and number 3. Question number 11. Not the type. Okay, principal migration. Okay, there is no such thing. Okay, there is no such thing as principal migration. Okay, all right. Yep, there you go. All right, catching up. Okay, Abdul Rahman is catching up. Second last question. Okay, what is not the factor of secondary migration? It is wettability. Okay, remember the second last slide, I think, right? Factors of secondary migration. Okay, it depends on buoyancy. Okay, what is the density? What is the buoyancy of the different fluid in your reservoir? Okay, it depends on the hydrodynamic forces. Okay, your structural tilting, tectonic forces, and also depends on the equilibrium forces. Oh, we have a new player on the podium. Okay, we have Inda. Okay, but I believe we do know who is leading the podium. And the last question. Okay, so the answer is true. Okay, vertical migration is always more efficient than lateral migration. Okay, 60% of the reservoir, okay, shows vertical migration. All right, let's have a look at our podium. Number 3, we have Adrian, congratulations. And then we have Inda and our champion.
Congratulations.
Okay, so we have Zadira Ayu, our champion. Okay, and our runners-up, Abdul Rahman and Muhammad. Okay, all right.
Okay,
Very good,
fun.
everyone. Good job, all of you. Okay, all right. Screenshot this one. Yeah, number 1, Zadira Ayu. Okay, all right.
Okay. Done.
So that is my sharing for today. All right. And if you have, we still have 5 more minutes in the meeting. So sorry for taking up the time, but yeah, I guess this is to supplement some of the conclusion that I have. Okay. All right.
Okay.
Right. So that is all. Mr. Shepperson, over to you.
Okay, thank you for Miss Elie for your presentation. It is really great, and this game is really amazing. Okay, before we end of this session, we have more session that is the question and answer session. So for the participant, for the student in this Zoom meeting, you can asking for some question to Miss Elie. You can open your video and your mic so you can tell what you wanna asking to Miss Elie. So silakan pada teman-teman yang ingin bertanya menggunakan bahasa Inggris atau menggunakan bahasa bisa membuka video dan mic-nya dan menyebutkan nama serta kelas. Okay, we have Rahmi Nurul here present. So Rahmi Nurul, you can open your video and your mic.
Thank you, Mr. Adam, for the chance. So I want to ask to Mrs. Ellie. How are you?
I'm good. How are you?
So my question is about whether the tribe is the reservoir itself or is it a different layer than the reservoir?
Okay, all right. So that's a good question. Okay. The question is the trap considered as the reservoir? All right. Is the trap considered as a reservoir? So when we look into the reservoir, all right, definitely we need to look at the entire essence, okay, of the what makes it as a reservoir. To answer the question, yes, trap or trap is considered as part of the reservoir. Hope that answer your question.
You can understand what Miss Elia.
Yeah.
Okay. Okay, is that enough?
I think that's enough. So I mean, like, actual term tribe is referred to peculiar structural, right?
Yep.
Yes, okay, because the entire topic is all about petroleum system, okay? And if you look into the definition of petroleum system, okay, in order for you to have hydrocarbon accumulation, in order for you to have oil and gas, okay, existence, okay, it needs to fulfill the elements of petroleum system. So without a trap, okay, you will not have petroleum system. And when you don't have a petroleum system, you will not have what we call as our pay or our reservoir. So yes, again, it should be considered as a reservoir.
All right, thank you.
Conventional reservoir. Yeah, conventional reservoir.
I'm so satisfied.
Okay, thank you.
Thank you. Thank you one more time, Mr. Adam.
Okay, that's a good question. Okay, next is from Adrian Hidayat Marstia. So you can open your mic and your camera and asking your question.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Yeah. Introduce. My name is Adrian Hidayat Marstia from 19 class.
Oh, our number 2.
I wanna ask about wettability. In wettability, there are two, namely oil wet and water wet. Which one is more beneficial to wet oil or water wet? And at which cost is cheaper? Thanks.
Okay, all right. So we need to refer to the definition first, okay, of the wettability. Wettability is defined as the ability of the fluid to spread on the solid surface. So you look into, what type of fluid that is actually attached to your grain. Okay, so when you look at the porous medium of our reservoir, right, we want to produce oil, we want to produce gas. We don't want oil, we don't want gas to be attached to the rock. So we have 3 types of wettability: oil, wet, and mix. Let's have a look at these 2 major wettability, which is oil wet and water wet. Oil wet means water attached to the reservoir grain. Oil wet means oil attached to the reservoir grain. So when you have water wet, since water is spread or attached to the reservoir grain, okay, the fluid that will be flowing around your porous medium will be your hydrocarbon. And in the case of oil wet, oil is attached. Now the oil is already attached on the grains. And the fluid that is free to move is water. We don't want to produce water, we want to produce oil. So the best is water wet. That is the first question. The second question was what? I forgot. Cheaper. Oh, okay. What's the
cheaper.
question again? I'm so sorry. Can you repeat the second question?
And at which cost is cheaper?
Okay, so in terms of which cost, okay, definitely, if you are drilling into a water wet reservoir, okay, it's going to be a very straightforward. Okay, you drill and then you can immediately produce because the movability of oil and gas is high. But if you are looking at oil wet reservoir, okay, you need to do alteration. Okay, you need to change the wettability in the reservoir from oil wet to become water wet. That is done, okay, by altering the property, the interfacial tension between these two immiscible phase. So yes, much more cheaper to operate if you have a water wet reservoir. Okay,
Thanks,
thank
ma'am.
you. All right.
Oke, jadi Miss Ellie mengatakan bahwa di antara water wet dengan oil wet, tentu water wet yang lebih menguntungkan dan dia itu bakal lebih murah karena kita tidak perlu menggunakan sistem kalau misalkan oil wet itu kita harus menggunakan EOR gitu, simple ya. Oke, thank you for Adrian Hidayat.
Bang, terima kasih, Bang.
Okay, and next question is from Abdurrahman Budi Arif.
Okay, thank you. Good morning, Miss.
Hi, good morning. You were on the podium, yes.
Yes. My name is Abdurrahman Budi Arif.
Okay.
I want to ask about migrations. Previously, you explained about the distance of movement. What I want to ask is, what about the time it takes to move from one rock to other rock? Does it immediately move, or it takes time, or what?
Okay, so again, all right. I think I did not mention this in the lecture. Okay, so in terms of timing, okay, actually, if you look into the more detailed components or elements of petroleum system, okay, whatever that I have mentioned is the basic 5. Okay, but you also have another 2 more. Okay, we have 7 in totals. But these other 2, okay, it is a very, I would say, minimum effect. So the first one is maturation, and the second one is timing. Okay, the second one is timing. So in terms of timing, this is relevant to maturation. So what it meant is you need to allow, okay, you need to allow your hydrocarbon to become mature before it can migrate. So that's why sometimes when we look into field classification, you have brown field, you have green field, okay, and sometimes when you do field exploration, okay, you decided that it is not time yet for you to produce because the hydrocarbon is not mature yet. Perhaps you can leave, okay, and then maybe in another 10 or 15 years, the hydrocarbon is mature. So that is where time scale is relevant, okay, that is where time scale is relevant, okay. We need to allow sufficient pressure, sufficient time, okay, and sufficient heat to properly cook up your hydrocarbon to become mature. Similar like you are cooking or baking. So if you bake, okay, and the recipe calls for 20 minutes at 150 degrees Celsius, but you only bake it for 5 minutes. So your cake or your dish is not ready. Okay, so similar like this process of cooking or maturity of hydrocarbon. Okay, and in terms of the time it will migrate, okay, it is in usually, okay, what happens is that organic material will be sedimented around the same time, okay, around the same time. And then they will undergo the same anoxic condition where it will be decomposed under no oxygen. Okay, they will decompose under no oxygen. And then when they were subjected into pressure, subjected into pressure and temperature, okay, depending on the type of kerogen that you have, it will follow a specific timeline. Okay, it will follow a specific timeline, and whatever that is mature, okay, first they will immediately be expelled, and whatever that is still not mature yet will still be remains in the source rock. Means that if you're already mature, then you can be expelled to the secondary, to the reservoir rock. That is in terms of timing. Okay, hope you answer your question.
Okay, Abdurrahman.
Okay, thank you, Miss.
Okay, thank you.
Okay.
Okay, Miss. We still have one questioner, but I will give that chance if you still have the time. Oh, two questioners. Okay. I think Miss Ellie sudah.
Okay. I saw someone raise their hand. Anyone wanted to ask question?
Yep. Do you still have a time? And we have
sure, of course.
questioners more.
Yes.
Okay. So the next question is from Ahmad Rivaldo.
Oke Bang, makasih Bang sebelumnya Bang. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Morning Miss Ellie.
Good morning.
Before we start, I want to introduce myself. My name is Ahmad Rivaldo from Bintan, and I want to talk about the sedimentary basins map. Okay, the question is, what are the advantage and disadvantage of using sedimentary basins map? And is there something new for innovation of sedimentary basins map? Miss? Okay, thank you. That's it, my question.
Okay, thank you. Sedimentary basin map. Okay. Sedimentary basin map, the importance of using sedimentary basin map in terms of exploration, is that what your question is? Is it in terms of exploration? Okay, right. So let me try to answer this. Okay, this is not part of the petroleum system, okay, but it is part of basin development. Okay, sedimentary map. In terms of exploration, why do you need to refer to sedimentary map? Okay, is because you need to predict where could be the next, or where could be the potential location of your reservoir. Okay, and majority of the reservoir is located in sedimentary basin. So if you have a map of a sedimentary, if you have a sedimentary map, okay, if you have a sedimentary bed map, then you will be able to predict, okay, you'll be able to predict at which particular depth where you would have hydrocarbon. Okay, this is during the initial stage of exploration. You refer to a map, okay, you refer to the, whatever data that you have, okay, you look at the phases change, okay, you have a look at your cross section, and then from there you can advise, okay, you can make interpretation that from the sedimentary map, okay, you could have, because when we look at sedimentary layer, they are, okay, we have a lot of layers. Okay, we have a lot of layers, okay, especially if you are looking at older formation, you have, too many layers. And where can you have oil and gas? So by studying the sedimentary map, you can actually predict or propose that at this particular layer, this is where you will find oil and gas. So this is the advantage of using the sedimentary map. That is the first question. The second question I forgot. Can you repeat, please?
Okay, the second question is there a new or something new for the innovation of sedimentary basins map?
Okay, so definitely we are looking into, all this artificial intelligence, okay, all this. So you see, oil and gas is a very classic industry, okay? We are sitting on top of a pile of data. we have too many data which were not recorded, which were not, which were not collected and digitalized, I would say, okay. And I would say the new technology that we can have here, okay, is in terms of artificial intelligence, where when you have a set of parameter, okay, you can predict, okay, you can predict basically whatever that you wanted to predict. For example, you have a map with this layer, okay, with this lithology, with this physical property, with this age, with this fluid dynamics, okay. And from there, okay, by using, when you train your data, okay, then this can give you the input that you want. For example, it can give you the time of when the hydrocarbon can mature. That's one. Okay, you can predict where exactly, okay, will they accumulate, okay, because when you visualize the reservoir, okay, and when you do simulation, okay, when you section your reservoir, okay, you can divide your reservoir into X, Y, and Z, okay, into a lot of, hundreds of different grid cells. So by using this artificial intelligence also, okay, you can predict at which particular grid cells or which particular layers, okay, will your hydrocarbon migrate and accumulate. That is the answer. One of the answers.
Okay, Miss. Thank you. Nice to meet you.
Thank you.
Okay, thank you for the question. I think the next question is from Sil Til Jiski Simajuntak.
Hello, Miss.
Okay. Okay.
Let me introduce myself. My name is Sil Til Jiski Simajuntak. I'm from A class. I see in your slide about salt dome. Can you tell me about salt dome and how the salt dome is formed? Thank you.
How salt dome
is
will form? Huh?
Yeah.
Is what? How is
forming.
it? Forming. Okay, okay. Yeah. All right. So the study of salt dome is another complex. No, I would say complex. Yeah, it's another different story. Okay, but salt dome is something that is growing. Okay, it is growing. So if you look into the development, okay, at this time period, it's like cave. Okay, cave is something that continuously develop. Okay, similar like salt dome. Okay, it started with a sheet. Okay, it started with a sheet of salt layer. Okay, or evaporites or halide, anything. Okay, and then over time, okay, it will try to intrude. Okay, it will try to intrude upward. Okay, so whatever that you are seeing now, that dome, okay, is whatever that, from a sheet, okay, it intrudes upward. Similar like the tectonic forces that, force igneous rock intrusion. Similar concept as salt dome formation. Okay, and in terms of property of salt dome, okay, we know that what is salt? It's basically something that has high salinity, okay? And in terms of structure, the strength, the formation of salt dome, okay, it is, salt dome is very brittle, okay? Salt dome is very brittle in terms of when you want to do drilling, okay? You will try to avoid to drill directly into the salt dome. Why? Because when you drill into the salt dome, since it is very brittle, okay, unconsolidated, it will collapse. So when it collapses, okay, it will cause a pipe, okay? And if you manage to drill through, okay, and manage to tap into your reservoir, okay, over time, okay, because of the high salinity, it will start to corrode your tubings. Okay, so that is in terms of production and drilling of salt dome. In terms of the formation, that is what you have to understand. Okay, it started with a layer, okay, a sheet layer, okay, and then over time it intrudes upward. That is the salt dome formation.
Okay, thank you.
Okay.
Okay, thank you for the question. This is the last question from Bunga Arafah Lianti. So, Bunga Arafah Lianti. Hello. Okay. Can you open your mic before you try to asking some question? Okay, great. You can hear.
Assalamualaikum warahmatullahi wabarakatuh. Hi, Miss.
Hello.
Waalaikumsalam.
I want to ask about the stratigraphic traps.
Okay.
What the difference about the stratigraphic trap result from variation in phases that develop during sedimentation and after the sedimentation? Is that given an effect from is that given an effect for the traps or cap rocks or what?
Okay.
Thank you.
All right. So, very good question. Okay, especially for stratigraphic map. So we have two types of map. Sorry, we have two types of trap: stratigraphy and structure. Structure is very straightforward. Okay, you have a rock. Due to forces, it will deform your rock, and then there you go. Your oil will be trapped there. For structural trap, this is another story. Okay, it is an evolution of your sedimentary layer. Okay, and over time, yes, okay, your trap will evolve. Okay, depending on what actually happened to your structure, basically. Okay, so usually, okay, the changes that we occur usually the changes that we observe occurred on our stratigraphic trap, okay, involves where you have, erosion. So when you have erosion, this will definitely alter, okay, this will definitely alter your trap, okay, especially if you are looking at a pinch out, okay, when you have a pinch out. And when you have mantle phase change, okay, or when you have intrusion of igneous rock, when you have ground movement, all this will also, again, give effect to your stratigraphy trap, okay? It results in the change in rock type. So if you have changes in rock type, okay, then your stratigraphic trap will also change, okay? But for structural trap, I would say this is a much more stable trap, okay, because it occurred after the sedimentation completed. Okay, so it means that you have already you have a complete sedimentation, and then you have the external tectonic forces. Okay, but for stratigraphic trap, the rock will continuously changes. Thank you.
Thank you, Miss. I think that's all for now. Makasih Bang Adam.
Okay, sama-sama. Okay, Miss. I think that is the last question from the participant. Maybe if the participant have more question, they can asking to Miss Fitrianti. So Miss Fitrianti can asking to you for the question.
Sure.
And before we end this meeting, I want to convey a message from Miss Fitrianti. She said she wanted to have the material that you presented today, and she hoped that the material could be sent directly to her.
Okay, I will do that right after this.
Okay, thank you. And for all the participants, untuk semua peserta, you can open your camera. Semuanya bisa buka kamera kalian. Kita akan mengambil sebuah gambar. We will take a picture for the documentation. And I will lead this photograph. So in my LRM. Oke, semuanya dari pack 1 ya, kita nggak tahu mana yang akan diambil. Jadi tetap buka kamera kalian. Keep open your camera. Okay, prepare yourself. Get ready. 1, 2, and 3. Okay, next slide. 1,
Adam, bentar,
2,
Dam. Itu siapa yang
3. Okay, the last slide. Okay. 1, 2, and 3. Okay, I think that was enough. And thank you to Miss Elie for your
Thank
time,
you, UIR, also for
for your
supporting.
presentation, and thank you for all the participants.
Adam, what happened to you?
Okay, I'm sorry, I have a problem with the connection. And thank you for Miss Elie and all participants. We're really happy for today, and see you again next time.
Thank you, students. Thank you for having me. I appreciate it so much. Thank you, Fitrianti. Thank you so much, and see you guys again. Okay.
Okay, nice to meet you.
Okay, thank you.
Thank you,
Stay
Monet.
safe semua.
Thank you. Bye.
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 Okay, maybe sometime the student can join to APU for maybe visiting or something.
Of course,
Mungkin suatu saat kalian bisa berkunjung ke APU karena kita masih punya program kerjasama. Jadi siapkan diri kalian, prepare yourself, prepare your English, prepare your knowledge and everything, because that will be great if you come to APU. Or maybe APU can come to Sumatra.
Yes, I want to go there. We will visit there.
Yeah, because we are already prepared for the last year, but this pandemic.
Pandemic. Hopefully this year.
Yep, that's right.
Okay.
Okay.
All right. So I will leave the meeting.
Thank you.
Good luck, everyone. Okay, and see you soon. Bye.
Thank you, Miss.
Bye.
Thank you.
Okay, see you. Bye.
Bye. Dah.
Okay. Thank you semuanya yang udah hadir, yang udah selalu standby. Terus belajar, jangan lupa, Dek.
Baik, Bang.
Ya, Bang.
Kejar
Terima
semua
kasih.
nilai mumpung lagi semester bawah nih, kejar-kejar lagi online nih gampang nilainya, Dek.
Enggak juga, Bang.
Oh.
Ada.
Thank you ya, Bang Div ya.
Baik, Bang.
Terima kasih, Bu.
Ya, Bang. Makasih, Bu. Bang.
Makasih, Bu.
Makasih, Bu. Bang.
Makasih, Bu. Makasih, Bu. Makasih, Bu.
Waalaikumsalam.
Ya. Waalaikumsalam warahmatullahi wabarakatuh. Waalaikumsalam.